Well, hi everyone. I've got an update for you on the emergency evacuation of the Rialto apartment complex in the Orlando, Florida area. I did a video about this situation last week and described that the 350 apartment residents there in this five-story building were evacuated on March 19th, 2026. I'm recording this video on April 7th, 2026. And the evacuation apparently was spurred by reports by one or more of the residents there of loud popping, observed cracking, and inability to open the door to their unit to leave. And this sudden onset got building officials there from the county of Orange County, Florida, to evacuate the building and then subsequently condemn the apartment building for occupancy. Subsequent to these events, the county required the building owner to obtain the services of an independent structural slash geotechnical engineer to evaluate the situation with this building. They published a letter last week, they being Orange County, Florida building officials. So I'm going to go through the contents of that letter and just give you my overall impressions as to the current state of the investigation and what the likely situation is, in my opinion, as best we know at this point. Now, before I dive into the details here, I want to make it clear I am not providing engineering services or specific guidance for this particular building in Florida. I'm just relating my experience with dealing with geotechnical investigations in general for areas that are subject or potentially subject to sinkhole development from karst topography, which I believe is the leading concern here, in my opinion, that should be investigated as to the potential cause for this building settlement. But I'm just going to go through the details here. But and I think these general principles should be borne in mind. And I've been a little bit frustrated by some of the local media coverage just being so nebulous, let's say. So this is the location, this area of Orlando, this unincorporated area called Dr. Phillips. And in my previous video, I talked about the phenomenon of a raveling formation associated with sinkholes, where you can have superficial soils, say silt, sands, and clays, overlying solution limestone bedrock, and over time, these joints or solution cavities can become wider and wider such that overlying soil passes into voids and joints and cracks in the underlying bedrock, which causes the formation of surface holes or sinkholes. And oftentimes these holes fill with water from the superficial aquifer or the perched aquifer on top of the limestone bedrock. Now, as I mentioned, the firm that was retained by the building owner on behalf of City of Orlando building officials. In this case, I thought it was Orange County building officials, but it says City of Orlando building official. And this company, SGH Simpson Gumpertz Hager. And I'm going to come back to the details of this letter. But if that name sounds familiar, it's because of the Millennium Tower. I've done many videos on the Millennium Tower on this channel in the past. That firm was retained to design the so-called fix for the Millennium Tower to address building settlement and building tilting. And the engineer with SGH was a man named Ron Hamburger, who I understand has since retired. And I attended one of his webinars, and he indicated this was his final project before he retired. So I don't suspect he'll be getting involved with this Rialto situation in Florida. But for the Millennium Tower, he designed initially a 52 pile system to underpin two sides of the building to arrest additional building settlement and tilt. And because the repair work apparently caused additional settlement and building tilting, the program was curtailed drastically to only 18 pile. And I've often referred to this as a so called fix. Uh, Mr. Hamburger stated in some instances that the repair wasn't needed and it was only done to help stabilize real estate values, which I don't think has happened. And then other interviews, he indicated that he thought this repair work was necessary. But at any rate, that's what happened on the Millennium Tower. Now let's go through this letter in detail. So this letter recaps the events of March 19th, 2026, relative to observations of the building distress and subsequent evacuation. And it didn't take them very long. They indicate SGH was out there by mid morning on March 19th and was hired, which unfortunate term. If you're in the business of providing professional engineering services, you generally want to say you've been retained. You don't want to sound like the old hired gun idea there, I suppose. But they were retained to investigate the cause of the event, and they got there the afternoon of the same day and began to investigate the cause or causes of the reported conditions. And they note that they observed cracks in the drywall of what they refer to as stacks 45 and 47, part of the building structure, along with jamming doors and floors that slope toward the shared bearing walls between the 45 and 47 units. Our initial observations indicated that a portion of the building had likely been displaced or otherwise moved downward. So this letter goes on to say this letter summarizes our current findings from our investigation and provides an overview of our planned next steps. So they did a document review of the building construction. They don't indicate whether or not they were involved with any aspect of the original foundation or building design for this apartment complex. The structural drawings indicate that the structure consists of parallel cord wood trusses at the roof and at each floor, which are supported by conventional wood frame bearing walls. The wood frame bearing walls are supported on the ground level concrete slab. The ground level concrete slab is 4 inches thick with post tension reinforcement and thickened conventionally reinforced haunches that create strip footings below the bearing and non bearing walls. Okay, so they make it clear that this building was constructed with a slab on grade foundation. So the soil is supporting the shallow foundation for this 5-story building. And the building itself is a wood frame structure, so somewhat settlement tolerant as opposed to something more brittle, say, with reinforced concrete if there was excessive movement. They go on to say we observed a gap between the soil and the ground level slab that extends underneath the load bearing wall footing between stacks 45 and 47. The gap is approximately 3 feet deep and 15 feet in diameter. At this time, we believe the lack of soil support below the slab on grade between stacks 45 and 47 resulted in downward displacement or other downward movement of the slab and wall. And they go on to say, as a result of the gap below the slab on grade, SGH conducted a thorough inspection of the remainder of the building and found numerous locations with gaps between the concrete slab and the underlying soil that range from 0.5 inches to 4 inches. There are no indications of gaps below the slab of a similar size to the one observed below the 45 and 47 stacks. We are in the process of developing a floor plan that details the approximate size and extent of these gaps. We will issue the floor plan once it is completed. Well, that's something I pointed out in my previous video. Mapping out the location and pattern of these cracks can be very instructive as to the potential cause of this soil movement underneath the floor slab. Now, one of the things I've noticed here is they don't say how they observe these gaps between the bottom of the floor slab and the soil underneath the building. And, if you're doing a data report, which this is mostly a data report, you should, in my opinion, include a description of how you collected the data. There's no information whatsoever. I suspect that they use ground penetrating radar on the bottom level floor slab. It's possible they drilled holes through the floor slab if they removed floor coverings to probe beneath the floor slab, but it's not at all clear what they did here. And it's not at all clear to me whether they conducted a complete survey of the entire footprint of this apartment complex. And it says that we will also conduct a subsurface investigation within and around the building to determine the cause of the gaps and the potential for future gaps to develop. Well, that's appropriate in my opinion. This will include soil borings around the building perimeter and performing cone penetrometer test soundings within and around the building. Geophysical surveys may also be performed. So, as I mentioned in my previous video, these are all typical investigation methods that will be employed in a situation like this, in my opinion. The anticipated duration of this work is uncertain, but may exceed 60 days, depending on the contractor's availability to mobilize on site and the time required to process laboratory sample. So, conducting geotechnical investigations within a building can be done. It's obviously more expensive. You have to use low overhead equipment. You have to direct exhaust gases from these type of equipment that have internal combustion engines outside the building. So a lot of extra work that has to be done to do an investigation like this. They go on to say that the building is currently safe for worker access and there's no concern regarding imminent failure of the structure. However, the building is not suited for continuous resident occupancy while investigation and eventual remedial activities are underway in areas where residency would happen. So, in that instance, I'd like to see a little more detail as to how they reached their conclusion that the building isn't fit for occupancy. I mean, it makes sense, but again, in a technical document like this, I think you should spell out your reasoning a little more clearly. I think it would provide better guidance to the people involved and better information to the public in terms of what they believe the situation to be from an engineering standpoint. They go on to say that access at this time should be limited to personnel involved in the investigation and remedial or repair activities and those gathering the residents' possessions and property. Engineers, investigators, and contractors utilizing appropriate safety equipment are inside the building performing the building investigation and removing residents' possessions and property. We will continue to provide updates on when residents may safely return to the building or to parts of it. And this letter closes with this investigation is still ongoing and these findings are subject to change. Well, that's a good thing to put in a report like this, I think. So here's an image of ground penetrating radar scanning equipment. You have these wheels and a cart, a underslung cart here with the GPR unit, and the radar signal is emitted from this unit into the ground. And it's a good method for locating voids right below the ground surface or your floor slab. It would not be a methodology, in my opinion, to characterize uh, much deeper zones of soil and rock, much deeper being more than, say, 10 to 20 feet. In my previous video, I mentioned that I thought it might be likely that the engineer evaluating this building would install crack monitors. There was no mention in the letter whether that is being done. But let's go through some of the details of this potential geotechnical investigation. So they mentioned soil borings. This is a split spoon sampler. This sampler is driven into the ground to collect soil samples, and the resistance to driving, that is the number of blows per foot, is recorded. That gives you some idea of the consistency of the soils. And a sample can be retained for characterization and for index laboratory testing, such as moisture content, grain size distribution, consistency tests for clay soils, Atterberg limits. This is a drill rig, typical geotechnical drill rig, conducting SPT sampling. It's a dry sample, and they're counting the number of blows per foot to advance the sampler. This would not be considered a low overhead rig. You have these rigs that have masts that can be folded down so that a rig like this or a smaller version of it can get inside a building. And they mentioned cone penetrometer testing. This is a small CPT rig. You have the cone that's pushed into the ground, you have an anchorage system, and its rods are pushed hydraulically into the ground. And you have an assortment of electronic instrumentation that is used to collect the data. So the signal cable is routed through to the interior of the rods, and you have various sized cone tips. Test measures the penetration resistance at the tip of the cone, as well as side resistance along the outer sleeve of the cone. And then oftentimes there's a centered metal disc between the cone and the sleeve where pore water pressures can be measured during the test. And this test is very quick compared to drilling and sampling for an SPT sampler. It does have some limitations, but you can get a pretty good idea of the soil profile and the soil consistency, and of course, depth to rock, because you're not able to push into rock with this type of setup with the cone penetrometer test. So, what would be the objective for an investigation like this? Years ago in 1992, I was responsible for conducting a geotechnical investigation for a proposed power plant in Kissimmee, Florida, so just south of this Orlando area. And the company I was working for, just working there for the summer, and my peers at that company were full time, and they had all worked there at least 5 years, whereas I had worked for the Corps of Engineers for 5 years before getting my master's. And I was working at this company that designed power plants the summer before I graduated with my master's degree. So they sent me on what they considered to be a very simple, routine investigation because I was the new guy as far as they were concerned. And as I recall, there were 10 borings planned, and the anticipated soil profile was 50 feet of clay and silts overlying limestone bedrock. And that's what we found in the first two borings. And then the third boring, I was at a depth of 120 feet and wasn't quite sure that I hit bedrock yet. So it was clear that we were encountering a solution cavity within the bedrock, a sinkhole, although the sinkhole had been filled in long ago. And it was interesting that the driller there was near panic mode because, normally you don't want to end a boring in loose or soft soils. You want to go until you get so called decent material, something that you could bear on with a deep foundation if that were needed. Although the anticipated type of foundation for this power plant was all shallow foundations, maybe 5 foot deep, but certainly nothing anticipated for deep foundation. So I was continuing the boring to try and get something solid, and we hit rock, what we thought was rock, at a depth of 120 feet. But to confirm if it was rock, you would typically core in that situation. And so the driller was again near panicked and trying to get me to immediately decide, are they going to terminate the boring and pull all their tooling out, or are they going to switch to coring? And he needed to know right away because he was afraid of a giant sinkhole forming around him and the drill rig, which was a valid concern. Interestingly, they were more concerned about that situation, basically the rapid development of a sinkhole that would swallow everybody up, than lightning a few days later. I mean, I could see lightning striking the edge of the clearing. We're in an open greenfield area for this proposed power plant, and I could see branches and leaves flying up in the air from lightning striking. And the drillers were telling me that it was at least 2 miles away because he counted to two between the lightning flash and the sound of the thunder. And I pointed out that you had to divide by five to make that calculation. So anyway, the fear of sinkholes was very real in the mind of this drill crew, and I think appropriately so. So as we know, this area of Florida has numerous areas of subsidence that have been reported in the past. I covered this in my previous video. There's also a sinkhole formation risk map. So the yellow is favorable to sinkhole formation, orange more favorable, red most favorable, and blue least favorable. So this area where the apartment complex is located is deemed favorable for sinkhole formation. And as I pointed out in my previous video, you see the red location pin for the Rialto apartment complex. You've got numerous round-shaped lakes in the area that I think are likely indicative of past sinkholes that formed and subsequently filled with water. Now you can have stable sinkholes, and the question is, could these sinkholes enlarge over time, or could you have areas that currently are flat and don't have any apparent subsidence subsequently develop sinkholes? So as I've stated, I think multiple potential mechanisms for the cause of this apparent apartment building settlement should be investigated. The potential for the activation or redevelopment of a sinkhole, I think, would be at the top of my list if I were investigating the situation with this building. Other potential causes could be uh, the rupture of utilities, say water lines or sewer lines that eroded finer grained or sandy soils that may exist below the building floor slab. One thing I'll note that this type of building foundation, this post-tension concrete slab, is not the type of foundation that can span large open areas in the ground surface. So this type of foundation, it doesn't have the internal structure to be designed to be supported by deep foundations, whether drilled shafts or driven piles. So if they determine, they being the engineer and the building owner and city officials or county officials, that say underpinning would be in order for this building, significant modifications I think would be needed to the floor slab to accommodate a deep foundation support mechanism. So I'll continue to follow this story. I think city or county officials so far have been very transparent about what they know so far and what's happened. So I applaud them for that. I think it's premature based on some of the comments that I received in the previous video to point fingers at anyone in terms of being at fault potentially for this apartment building settlement. The fact is that these sinkholes can develop, they can be a surprise. It's very difficult to do enough subsurface investigations to fully characterize the risk at a site. And I don't know what was done in the past. And so I'm not going to weigh in on whether that was adequate or not. I would just say, in general, if people want zero risk for sinkholes forming under their buildings, they shouldn't build buildings in a large swath of Florida, which is frankly untenable, I think. So there has to be appropriate investigations and risk management. And I'll continue digging to because I'm just curious to see what was done originally for this apartment building location. With that, I've got another book recommendation for you all out there. I've read a lot of books related to Stoic philosophy. That period in Roman times is extremely fascinating to me. And this biography of Marcus Aurelius is what it sounds like, a biography that puts a lot of the events of his life into a much sharper historical focus. And Roman society is extremely interesting. And of course, many people have drawn parallels to our current situation with our civilization and what ultimately happened to Roman civilization. I'm not making that statement on my behalf here, but it's a very interesting time. A lot of interesting concepts that seem fresh today that were really developed thousands of years ago. So that's very interesting to me. If you're inclined to check this out, there's a link in the description. With that, I want to send a shout out to those of you who've contributed to buy me a coffee. That's one of the better ways to support this channel. I also want to thank those of you who are channel members who typically get to preview these videos one or more days in advance. And I also want to thank those of you who contributed to super things. So stay tuned, everyone, for future videos. I'll continue to follow this story.